Um, can we start now? So I think Dr. Susan.
Yeah, I'm here.
Okay. So good afternoon, all of you. So actually, after a gap, we are starting our webinar session again. This is the 12th session of our department webinar series, and I'm very happy that today we have an expert from the industry, Dr. Susan Zachariah, R&D engineer, Sending Tech Holding Limited, Taiwan. She will be talking about polymer coating for anti-corrosion application. How nature inspires your ideas. I welcome all of you to this webinar session. Especially, I welcome Dr. Susan Zachariah. And now I invite Dr. Anuj Vargeese to introduce Dr. Susan Zachariah, the speaker. Over to Dr. Anuj.
Good afternoon, everybody, and welcome to Dr. Susan. So, Dr. Susan Zachariah, who is currently working as a research and development engineer at Zending Technology Limited, the company which is a Taiwan-based company and which is mainly engaged on the design, development, manufacture, and distribution of printed circuit boards, and as well as semiconductor-related products. And Dr. Susan obtained her PhD degree in chemical engineering from National Tsinghua University, Taiwan. Before that, Dr. Susan obtained her master's degree in biopolymer science from CIPET IPT Kochi campus, Kochi Center, and bachelor's degree in industrial chemistry from St. Paul's College, Kalapassiri. Dr. Susan, during her PhD tenure, has been working on mainly on the incorporation of hierarchical surface structures to polymers through biomimicking process for anti-corrosion and membrane separation applications. And during the PhD, Dr. Susan has worked on polybenzoxime-based anti-corrosion coatings with lotus leaf pattern on the surface for metal protection. This coating has successfully protected the coating was successful in protecting from the corrosion, and it gave a protection efficiency of 99.93%. And again, Dr. Susan worked on the research worked on the polybenzoxime and carbon nanotube functionalized with the same polymer based on anti-corrosion coating for metal protection. The protection efficiency was 99.91%. Also, Dr. Susan worked on the polyvinyl alcohol-based membranes with the lotus leaf pattern on the surface for desalination. And Dr. Susan has published many papers in the reputed journals, and as a research and development engineer at the Zending Technology Company Limited, she has been mainly focusing on making new PCB models for special applications, troubleshoot issues in processing, inventing new processing steps, and materials, and design to existing models according to the application. So with this, I request Dr. Susan to continue with the presentation. Thank you.
Good afternoon, everyone. Is it audible for everyone?
Yeah, you're audible.
Yes.
Good afternoon, everyone. Thank you, Dr. Anuj Vargeese and Sujit sir, for introducing me. Today, I would like to talk about one part of my thesis. As already Anuj sir introduced my topic, entitled Incorporation of Hierarchical Surface Structures to Polymers through a Biomimicking Process for Anti-Corrosion and Membrane Separation Applications. Among this, I choose a topic entitled Polymer Coatings for Anti-Corrosion Applications, How Nature Inspires Your Idea. So I would like to start my talk by remembering the quote of John Mayer, that in every walk with nature, one receives far more than he seeks. So I would like to tell everyone to open your eyes to the nature, and nature will give all the solutions for your troubles, and you get a better innovations from the nature. I will be dealing with the contents, nature, the motivation, Lotus leaf-based coatings for anti-corrosion applications, how carbon nanotube can help in reducing corrosion, pervaporation techniques, and membranes for seawater desalination. First, about the nature. Of course, all in my cases, in my PhD work, many of the works are deal with the nature. In this picture, what you can say is a leaf with some droplets of water. From this, you can get an idea that this leaf is not absorbing the water. It is repelling the water. So this have a property of super hydrophobicity. It's like hydrophobicity, hydro, water, phobic is the hate. So hydrophobicity. So here the leaf is repelling the water out of it. And in this picture, you can find a serious problem that the world gonna face in the near future, the scarcity of water. Our world is full of water, but the drinkable water is rare. So what we can do is transformation of this non-drinkable water to a drinkable one that we can invent. Another issue which I deal with is corrosion. In the presence of moisture and water, we can find many of our metal particles have corroded. So comparing to the picture 1 and picture 4, the last picture, you can see the first picture, the lotus leaf or the whatever the leaf is, it is repelling out the water. So if this water repelling property, if we can make this property to a metal, so the water will not go inside the metal so that we can avoid the corrosion. So if we can make a coating over the metal of this kind of property, it will be helping for anti-corrosion. These are some of the pictures. Some of the animals or plants have this kind of property, the super hydrophobic property. Before that, I would like to tell about biomimetics. Like nowadays, many of the researchers are focusing on nature and mimicking the nature's idea. So biomimetics is the art and science that we learn from the nature and we implement that in our applications to get the solution for many problems. So here you can find many kinds of plants and animals, including butterfly wings, lotus leaf, rose petals, have this kind of property of repelling the water from the surface. I would like to talk about lotus leaf base coatings for anti-corrosion application. This was one of the work that I have done in my PhD. In this picture, you can find the lotus effect. That is like the lotus leaf have some of the nanopillars on their surface that will make them repel the water. This have a high contact angle and this will repel out the water, so that you can find always the lotus leaf is clean and pure. So if we pour some water onto the lotus leaf, the water will get rolled out, taking all the dirt from the leaves. So that's why the lotus leaf is seen as a divine and pure one. The issue that I focused on is the corrosion. This is a corrosion cycle of steel. So I used a steel called coil rod steel for my application. So here, in a finished steel product, when in the presence of air, moisture, it will form rust, and it will go as iron oxide, and then again we use this for the preparation of the new products. So in this stage of the presence of air and moisture, if we can avoid that on the surface, then there will not be any corrosion on the steel. These are some of the pictures that shows the corroded particles that make some problems in your applications. So if we can avoid the presence of water and air, then it is easy for us to control the corrosion. This is an animation just to show how a lotus leaf acts when we drop a water on it. So due to some of the particular structures or on the surface of the lotus leaf, the nanostructures, nanopillars, this lotus leaf have high contact angle, and it will repel out the water. And whenever we pour water on the surface, it will roll out and clean the surface of the lotus leaf. I used lotus leaf and also another leaf called Sanasoma sagitifolia leaf, and this also showed the same property of superhydrophobicity. In my work, I have compared both the leaves. So for making a structure similar to lotus leaf, first we need a negative template that can take the structures of lotus leaf from them and give the structures to the polymer coating that we use for the coil rod steel. So a negative template acts as a mean which takes the complementary structures of the lotus leaf. So if the lotus leaf is having a peaks, then this negative template will be having holes on it. So again, when we place this negative template on the polymer coating of our coating, when we place this on the surface, we will get the actual structure of lotus leaf on this coating which we applied in the coil rod steel. So choosing a negative template, it's like it should be deformable, soft, it can be used for many times, and it should be easy to control. It should be simple and highly faithful to the original template patterns. The polymer which I have used as negative template is PDMS. These are the properties of PDMS. It is having a high elasticity, chemical resistance, appreciable flexibility, transparency, chemical resilience, and ease of fabrication. Now, polymers for corrosion protection. The requirement of the coating, the polymer which we use is it should have high adhesive property to the metal. So even though if we use a superhydrophobic polymer on the surface, it should be adhered properly to the surface, or else in the application time, it may peel out. So adhesion of the polymer is one of the major requirement. Temperature resistance, so that they must not degrade. Resistance to moisture, chemical, and salts. The polymer which I have used for coating coil rod steel is polybenzosazine. This is a preparation of polybenzosazine. It is prepared using a primary amine, formaldehyde, and phenolic compounds. The properties of polybenzosazine includes it have near zero shrinkage, very high char yield, it have good mechanical properties. Glass transition temperature is higher than curing temperature. Good electrical and dielectric properties. Low uptake of water molecules, so that in the present it have some hydrophilic functional groups. So this polymer itself will repel out the water. So it will enhance the application. The polymer is also hydrophobic, and we are implementing the structures over it. So it will give a bonus point because of this polymer's characteristic. Ring opening addition reaction, which yields no byproducts, a clean reaction. High molecular design flexibility. This is the flowchart which I have used in my research. So I have used two kinds of leaves. One is lotus leaf and the other one is Xanthosoma sagitifolium leaf. In this leaf, I have poured the PDMS solution over it. It is heated for at 60 degrees Celsius for 24 hours. So it gets solidified on the surface of the leaf. Once it is cooled in the sense room temperature, it is peeled out so that we get a complementary structures of lotus and Xanthosoma sagitifolium leaf. So you can find the lotus leaf having a peaks, it have a complementary holes on the PDMS negative template. On the other hand, I took the cold rod steel, cleaned it properly, and poured this polymer solution, which I have used is polybenzosacin in NMP. And this is coated over CRS. Here, I have used different temperatures to see the adhesion or the how this PDMS negative template act on it. So I have used different temperatures, different time for the heating. So temperature is a constant, and I gave different times. For example, the best result came when I kept this CRS PVC coated CRS for 60 hours. It gave the best complementary best structure of lotus leaf. So I have used different time like 60, 70, 50. So I have given different time to keep this. Before keeping the PDMS negative template, I have given different time to make it a little bit cure, a little bit hard, and then placed the PDMS negative template over it, pressed and heated. After curing the PVC, I have peeled out the PDMS so that I found the PDMS got the similar pattern of the leaf which I have used. This is the flowchart of the experiment which I have done. So here, this is the preparation of polybenzosacin. Is a primary amine, formaldehyde, and these are mixed in solvent, toluene and ethanol, and heated for 80 degrees Celsius. Finally, it is cross-linked, and we got the cross-linked PVC material. So some of the resultant discussions I have given. To check the properties of benzosacin, we have checked the FTIR, TGA, DSE, and GPC to find the number average molecular weight. These all we have done to check whether the PVC have the actual properties of the earlier works. And after coating, the test which we have done is first as it is the water contact angle. The water contact angle is a must do thing to find the hydrophobicity. If the water contact angle is high, it means it have more hydrophobic nature. So here I have given some of the names which I have used in my work. So first image, picture A is the water contact angle in lotus leaf, that is 146. And second one is after curing, after placing the PDMS and curing, which used a 60-hour pre-treatment. It gave the best water contact angle. It is 147. And to check if we go beyond the time, like from 60 to 72, we checked for it and we found the contact angle reduced. So we made the optimum we have used 40, 50, everything, like, and best one obtained is at 60 pre-treatment. So we made it as an optimum temperature, optimum time for pre-treatment. And the same way, in the same way for the Sanasoma sagittifolium leaf, the contact angle was less than Lotus leaf. It is 141. And the same pre-treatment time we compared for 60 hours, and it gave 138. So we found the best sample which we obtained is Lotus leaf based cross-linked PVC treated for 60 hours, and the contact angle was 147. This is the SEM images of the work. The first image shows the pure Lotus leaf, and figure D shows the pure Sanasoma sagittifolium leaf SEM images. Figure B and E shows once the PDMS is attached to it, so it's the complementary structure. And figure C and F shows the final product. Figure C is the Lotus leaf based cross-linked PVC pre-treatment for 60, and F is same sample with Sanasoma sagittifolium leaf. These are some of the images of SEM and comparison. The figure A is Lotus leaf, figure B is the SEM image of it, figure C is Sanasoma sagittifolium leaf, and D is the SEM image of that. And here figure E shows Sanasoma sagittifolium leaf cured for pre-treatment for 60 hours, and its high resolution image. Figure G is Lotus leaf based 60-hour pre-treated cross-linked PVC coating, and this was the best sample which we got. In the same way, we also checked upon increasing the pre-treatment time, the structure is a little bit smooth compared to 60-hour pre-treatment. We also checked the roughness and found the Lotus leaf based coating had more roughness property than Sanasoma sagittifolium leaf roughness. This is the TAFL plot and BOT plot for checking the protection efficiency of the sample. Here in the first picture, we have used different days like 24 hours, 48 hours, 60 hours, 72 hours of pre-treatment before keeping the PDMS negative template. So we found the best sample which shows the maximum protection efficiency is pre-treated 60-hour pre-treated Lotus leaf based cross-linked PVC, and the BOT plot is also successfully showed the same results, like Lotus leaf based cross-linked PVC for 60 hours gave the best result. This is all about the I-core value, E-core value, and protection efficiency and contact angle of all the samples. We checked the bare CRS and simply PVC coated CRS with Lotus leaf pattern pre-treated for 24 hours, 48 hours, 60 hours, and 72 hours. Also, and in the Lotus leaf case, we found the best result in 60-hour pre-treated sample. So we compared Sanasoma sagittifolium leaf also at the 60-hour pre-treatment, and the best sample, which is Lotus leaf based 60-hour pre-treated cross-linked PVC, gave a water contact angle of 147, and it gave the I-core value of 0.028 and the protection efficiency of 99.93%. We also checked the stability of PVC coating later on. Like the contact angle checked with DI water, NaOH, HCl, hot water. So whenever we use NaOH on the surface, the contact angle reduces. And then once we use an acid, the contact angle increases. And we also checked the property when we heat the sample, and even though if we gave a harsh environment and heat, it finally gave a good contact angle above 145. And here we have soaked the CRS PVC coated CRS in NaOH for 7 days, and we checked whether it shows a good property, good characteristics as before, and find the water contact angle reduced for 140, but still it was okay even after 7 days, and we obtained a protection efficiency of 93%. So this reduction must be because of some problem happened in the surface. And in the conclusion part of this work, the first work, we have made a single component anti-corrosion coating with high protection efficiency. And here we have obtained a protection efficiency of 99.93%. And we also used a nature-based biomimic lotus leaf to get this pattern. So, and moreover, this crosslink PVC based coating also exhibit high stability in harsh conditions, so further validating its potential applications. Next, I would like to talk about how carbon nanotube can help in reducing corrosion. So in the earlier work, we used the property of surface patterns as we used in Lotus. We can see in Lotus leaf. Here, without using a surface property, we are adding carbon nanotubes on to the same polymer to check the property change in the anti-corrosion. So we did this because we found when we use Lotus leaf, if we use Lotus leaf based nanostructures on the surface, so if it is scratched or if it have some problem in the applications like on the surface, so it may affect the property. So if we are using some kind of reinforcement to make a composite coating, it may not affect the surface. So here we use the multi-wall carbon nanotube. The properties of CNT are it have good electrical, thermal, mechanical, and magnetic properties. It has good surface property and wettability. The main problem in using CNT is the dispersion of CNT. The carbon nanotube is in nanoscale, so it will agglomerate together if we are trying to coat it. So the first challenge which we need to say is how to disperse CNT, and also it should get a better adhesion with the host polymer. So these are the two challenges. One is to disperse it properly and to get a better adhesion with the host polymer matrix. So what we have done is that functionalization of the CNT with matrix or host polymer. So we were thinking to make it disperse properly and to get a good adhesion with the polymer. Why can't we use the same polymer to functionalize the CNT? So here, the matrix polymer itself is used to functionalize the CNT. So this is the experimental section. So first, we have prepared a polybenzoacetic solution with NMP, and CNT is added on it. We also added BPO for enhance the reaction. And finally, we got a CNT which is functionalized with PBZ. So this PBC functionalized CNT is used as a reinforcement to the matrix, which is the PBC solution. So this PBC CNT particles have been added to PBC solution, stirred it, and this solution is used as a coating. So this is the schematic representation. So it's like we have made the radicals on and through radical transfer we have made the sp2 bonds of CNT to connect with PBC and made sp3 bonding, so that the PBC particle functionalized PBC is attached to the CNT, and we have checked the properties using Raman and XPS. So we found it have a good functionalization with D by G ratio, reduced D by G ratio. And here we have after making a PBC molecular weight PBC multi-wall CNT, this is added onto the PBC solution, mixed it properly and coated over CRS, so that we found compared to without functionalized one, this functionalized CNT gave a good dispersion on the surface and good adhesion with the polymer. I'm not discussing all the experiments we have done. Just I'm gonna discuss on the main application that is anti-corrosion. So here we have checked the protection efficiency of the coating. We found even though the water contact angle was less, the property of CNT, the electrical property of carbon nanotube, made the coating a good protection a good protection on the for the CRS. So here we have used different weight percentage of CNT, PBC functionalized CNT, like from 1 to 4 weight percentage, and we found that when we used 3 weight percentage of PBC CNT, it gave the better protection efficiency of 99.91%. So we made this as the optimum percentage of functionalized CNT to add on to the PBC solution and to make the coating. So the conclusion of this work was we have used an anti-corrosion composite incorporating a matrix functionalized CNT, and PBC was developed with excellent anti-corrosion activity. And also we got the optimum weight percentage as 3 with an protection efficiency of 99.91. Next, I would like to talk about pervaporation techniques and membranes for seawater desalination. This is a little bit different from the other works, but here also we have used the lotus leaf property to get a membrane with lotus leaf pattern. So seawater desalination, what's the need of doing a seawater desalination? Because the scarcity of water. So the options that we have is taking seawater, desalinate, or use wastewater recovery. So I'm going to discuss on seawater desalination. There are different techniques, say thermal techniques, membrane techniques. Here I use a membrane technique. There are different types of membrane techniques, including nanofiltration, vacuum membrane distillation, reverse osmosis. The reverse osmosis is a very common technique where we apply a pressure and through the semi-permeable membrane, the pure water is obtained. This have the popularity because of its ease of preparation, energy saving capacity, good efficiency, low operational cost, small footprint. But it has some of the problems, like it requires high energy, high transmembrane pressure, high concentrate. If we use highly concentrated feed, then increase of energy cost, poor performance in case of high saline feed, pre and post treatments, and membrane fouling. So we use a technique called pervaporation. As you can see the term, it's pervaporation. It's like we can divide into two, like per and evaporation. So it's like membrane using a permeation through the membrane and then evaporation. So it's like we take the feed solution and this liquid is passed through a membrane So it permeates through the membrane, and later here we give the heat and make the permeate to a vapor stage. So after this evaporation, we get a vapor, and this vapor is condensed to get the pure water permeate. And this is compared with reverse osmosis and found that this is a better one that we can use. And this, even at low temperature, we can use, and even we can use waste heat to produce this. And extensive pre-treatment is also not necessary. And potentially low fouling occurs in hydrophilic membranes. This is the process, like feed solution is passed through the membrane, and it have used NaCl, so seawater desalination. So NaCl and water. So the water will pass through the membrane, and the salt is rejected. So we use pervaporation membranes. This work is actually not published, so I will not be discussing much about this, but I just want to tell what process we used. So same like the first experiment, we have taken the lotus leaf and poured the PDMS over it. After solidifying, the PDMS is peeled out so that it have the complementary patterns of lotus leaf. Then this is placed on a glass plate and stick to the glass plate. The PDMS with holes is placed in a glass plate. Over this, we have used PVA solution, and after it is heated, the PVA is peeled out, and we found the PVA, the lotus pattern PVA have similar patterns of lotus leaf. But for the pervaporation, we need to get a hydrophilic membrane. But once we get this patterns, as we already discussed, it becomes hydrophobic. Why we did this is to get good mechanical properties, but to make this hydrophobic PVA to hydrophilic one, more hydrophilic one, we deprotonated it using NaOH, and finally we got a membrane with lotus leaf patterns and hydrophilic nature to use it for salt water or seawater desalination. This is the process which we have used. Since this is in a review stage, so I'm not discussing much about this work. So now I just want to talk, say about Taiwan, where I live in. In 2016, I came to Taiwan after my master's in CPET IPT Cochin. So this is the map of Taiwan. Taiwan is a small country, which the area is even less than Kerala. It's a very small island, and I think I have traveled full Taiwan. It's very small country, and this picture shows the 101, which is a building in Taiwan. It was the world's highest building before Burj Khalifa was made. So still 101 is famous here. And National Tsinghua University. The picture is shown. This is the university which I did my PhD. There are many Indian students coming here for masters, bachelors, and even for PhD. And for the students who do masters, I can say if you get a chance to do an internship here, please try to do. So actually for going abroad, all the universities will be seeing your publications in masters. So do choose a good place to do your internship. And the final picture is Sending Technology Limited, the company which I am working. So this company is basically based on printed circuit boards. So here, since I'm from a polymer background, I deal with the problems that they face in polymers, like seeing what polymer should be used in which application. For example, comparing the ED and make the flowchart for the process of PCB manufacture. Basically, this company is of manufacturing, and I am in a research and development department. And this department is also divided into different parts, and I'm in special projects section. Here, they mainly use special applications, advanced materials for these kind of radar or military purposes. So here we are innovating some of the materials to be used, and also changing the design to make it more applicable. Yeah. So by this, I conclude my talk. Thank you for your attention. Thank you.
Thank you, Dr. Susan. Thank you for your nice presentation. So we have heard about the different techniques which Dr. Susan has used for corrosion protection, as well as the second slightly different topic on desalination, where the Pervaporation was used. Okay, and as Susan has discussed, the techniques which is adopted or mimicked from the nature was giving around 99.3% of protection efficiency, and we have seen that mimic those if patents the remote, we could make use of that patent for protecting these metals. Okay, so now with this, the session is open for discussion, and you can either ask the questions directly to Dr. Susan, or you can type the question in the chat window, so that we can pick the questions one by one.
Dr. Susan, I'm Unnikrishnan here from NIT Calicut.
Hi, sir.
Very pleasant to speak to you, Susan.
Yeah, thank you, sir.
How is the weather there now?
Here it's winter season now, so it's a little bit cold.
Okay, have a pleasant time.
Yeah, thank you, sir.
So two questions. One is, you have used two types of leaves, Xanthosoma sagitifolium and the Lotus. What is the difference in the type of patterns being formed on the template when we use these two leaves? Because their morphologies are definitely different, as highlighted by the SEM.
Yes.
And in what way it affects the performance?
Yeah. So we have used the Lotus leaf and Xanthosoma sagitifolium leaf. And first of all, we checked the patterns of Lotus leaf and sagitifolium leaf. And soon after we checked the water contact angle, it showed Lotus leaf have higher contact angle compared to the Xanthosoma sagitifolium leaf. One thing, even after getting the pattern of both the leaves, the trend of water contact angle is the same. Like the pattern which we used Lotus leaf gave more contact angle. Other thing which we noticed is, like, even in SEM we found the peaks which the number of peaks formed with Lotus leaf was more compared to the Xanthosoma sagitifolium leaf. So it shows Xanthosoma sagitifolium leaf was not getting more attached to the PDMS, so that the number of peaks were less. These were the two things which we checked. So that's why we compared for the same pre-treatment time. We compared both even after the final product, and find the protection efficiency is also lower for the Xanthosoma sagitifolium leaf.
Okay. So that's a very good observation. And secondly, you have looked into the PBZ viscosity. You said that PBZ is, you have evaluated the viscosity. And what is the influence of PBZ viscosity? Did you observe any optimum viscosity for a better performance for PBZ?
For this work, actually, we haven't used this viscosity. This viscosity, actually, to be frank, this inherent viscosity we have checked according to the reviewer's comment for the publication. So in our work, the inherent viscosity, we haven't compared anything with the inherent viscosity. Frankly saying, this inherent viscosity we have added only because the reviewer, when we published the paper, the reviewer asked us to add this point also for the future, like maybe for the future paper review.
Because it is a reflection of its molecular
Yes.
mass, obviously.
Yes. Yes.
Yeah, very, very good. Very, 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 very interesting work. Great. Thank you very much.
Thank you, sir.
Yes, thank you, sir. Any more questions from the audience? Okay, Dr. Susan, I have a question. Like the structures which are shown in the slides were very fine microstructures. Okay, so it's kind of that negative template means we are using it for a kind of dye. So when we have this kind of very fine microstructures, do we have to take any special precautions so that the fine microstructure patterns are not lost, or we just pour the polymer on top of that one and peel off, it will still remain there?
For this, like, actually, when we use the Lotus leaf, I'm just concerning about Lotus leaf. So Lotus leaf have many patterns over it, and we use the PDMS negative template over. And once it is solidified, the PDMS have got all the holes on it. It's complementary to the Lotus leaf, and we carefully peeled it out because like for PDMS it was okay, but after we keep the CRS, the PVC coated CRS, the placing of the template and pressing, and after peeling out, it was done very carefully. Like we haven't used any different equipments for it, but just we use the tons stencils which we can use, which we peeled out very smoothly, because and we haven't touched the surface after peeling out. Even for all the tests, we haven't touched the surface, so we peeled out very carefully, and soon after that we actually all the tests we have done immediately. Only the test after soaking in 7 days in NaOH we have done for a long time. That's why I have mentioned that a little bit reduction in protection efficiency and water contact can happen. And I believe that is because since this have the surface phenomena, and if we are not carefully dealing with it, it may affect the properties. So we haven't used any other equipments for it. We just made careful even not to touch the surface.
Okay, thank you. So the viscosity and the flowability of the polymer, the PDMS was not very important. That no. Okay.
Okay. Anuj, you finished? Can I ask some questions?
Yeah, sure.
Yeah.
Please.
Dr. Susan, this is Dr. Chinnaswamy from NIT Calicut. So I have a couple of questions. So the second part of your talk, like a corrosive, anti-corrosive, you used with CNT and all. This anti-corrosive is a permanent or a temporary anti-corrosive? Whatever you use the material, is the like a anti-corrosive material you used. This when we are using this material, it is like a permanent anti-corrosive, or again the material can lose its property, again it corrosive will come. Like,
In the case, okay, sir. In the case of carbon nanotube based coating, it for that I can say it will not lose its anti-corrosive property. In the first experiment with the lotus leaf, I can say even if there is any scratch or anything on the surface, it may affect its property. But in the case of carbon nanotube based polymer coating, the CNT, due to some of its electrical properties, and also it is mixed with the matrix properly and dispersed. Also it's not the surface property. I'm sure that it will retain its property even in harsh environment, and it have a good bonding so that it was not peeling out. So in the case of carbon nanotube based coating, I believe it will last for long compared to the first work.
okay, did you monitor that anti-corrosive property? Like you are taking some kind of thing and you coated your material, you monitor for long time, like that. You did something like that.
For this work, we have one thing I can say is that for example, we write the paper for it, and the reviews were coming after 9 months. So even after 9 months, they asked us to do some of the experiments, and I have used the same sample which I have made 9 months before to do the other characterization. So still the properties were retained in the same sample. And for the adhesion property, what we have checked is that we use a knife to make a plus sign on it and use a tape to place over it to check whether it will peel out or not. So even after 9 months, it was still having good adhesion and good properties.
Okay, that's good. And your last part of your work, you used some desalination kind of thing. What kind of mechanism is there in that, like in between like a salt and your membrane? What kind of interactions and what kind of mechanism? And why only the water is coming, not with the salts? And what kind of mechanism is that? What kind of mechanism you proposed, or something like that?
Okay, so we use polyvinyl alcohol, which is hydrophilic. So here we made after all the experiment, we made it. We also did deprotonation to make it more hydrophilic. So final membrane is highly hydrophilic, so it can pass water through it. And in pervaporation machine, we will be using we will keep the membrane over it, and we give the salt water. And since the membrane is hydrophilic, it will let the water to pass through, and soon after it is permeated, the machine will be giving heat so that it directly comes as a vapor, and in the final stage as it condensed, and we get pure water. And finally, what we got is that we compared with different temperatures, different salt concentrations, and we check the water flux and also salt rejection. So in the case of the membrane which we used, after deprotonating, we found it's got a higher water flux, which resembles the good water permeation, and we got a better salt rejection that resembles the salt as being rejected from them. And this hydrophilic membrane let the water to pass through, and the experiment, the final results of water flux and salt rejection made it properly showed that the membrane is hydrophilic enough to pass the water.
No, still I didn't get an answer from whatever I asked. Actually, I'm asking the what kind of interaction did you observe with the membrane and with salt? Because actually you are telling that the salt rejection is happening. Why salt rejection is happening? What kind of interaction is there? That still I didn't understand actually.
Yeah, so we are using salt water, and
Yes.
the membrane is hydrophilic. So hydrophilic means the membrane can pass the water through it. So it is allowing the water to pass through than the solid. And in the pervaporation mechanism, it allows it soon after it passes, it heats. So the hydrophilic will pass the water through it and it will directly get into the vapor stage.
Okay. What is the status of salt?
Salt is not passed through the hydrophilic.
You were eating the membrane also. When the passing through the water through the membrane, you want to heat and you will condense and you will get a pure water, right? That membrane itself you are heating, or after the passing through the membrane you are heating?
Yes.
What temperature you are heating?
The machine itself is heated, and it's like, yeah, the water is passing through it, and it's like a cell, this much part, a cell, and it is completely heated here. So what happens is that the salt water will touch the hydrophilic membrane, and since it is hydrophilic, it allows water to pass. So yeah, so the water is passed through it, and immediately it is made into a vapor, and final stage it is condensed. So the salt is not passed through the membrane because it is hydrophilic. It allows water to pass first.
How much temperature you are heating? What kind of temperature ranges you are using to heat that membrane?
Yeah, we have used temperatures. The maximum temperature we have used is 75, and the concentration of NaCl we have used is 3.58%.
Yeah, but to 75 you are heating, I don't believe the water will evaporate, right?
If we are making to 75 degrees Celsius, what happens is that the water flux, of course, will increase because it, it increase, and salt rejection as the percentage is reduced. So it means little bit salt is also added to it. But in the pervaporation experiments, first they will be seeing at room temperature and passing through the room temperature and giving 35 degree, 40 degree and 70 degree. But you are correct that 75 degrees Celsius, some of the particles are also passed. So in our work, we have mentioned that too. We made an optimum temperature for the passage and water. After that temperature, how it affects the salt penetration also we have made an analysis.
So what you observed from that experiments, whatever you discussed just now, the salt is passing through the membrane after some time when you are heating them.
If we are heating for a long time, if you are just heating for a long time, the salt rejection is reduced.
Okay, that's fine. Very good, Dr. Susan. Very good. Thank you very much.
Yeah, because I this work is on a stage of review, so I cannot say full everything.
That's okay. Thank you very much.
Thank you.
Any more questions from the audience?
Dr. Anuj, I think there's a question in that, two questions are in the chat box.
Okay, sir, it's not in mine, so I think...
Okay. So I will read. Dr. Susan, can you read that?
In mine also, there is no questions.
Okay. Then I will ask for them. Otherwise, Mayuka can also ask. Mayuka is there? Hello, Mayuka. Mayuka Lakshmi.
Yeah.
Okay. Anyway, I will read the question. How many such negative templates can be made from one leaf? How many such negative templates?
That's a good question. Actually, yeah. Once we actually use pure lotus leaf, the in the first experiments, like that is not in the publication, we have tried with dry lotus leaf also. Later we found in dry lotus leaf, when we use it can only take 1 or 2. After that, it like the peeling out is very difficult. So once we started using the fresh tender, like fresh lotus leaf, it is very easy to, after solidification of PDMS, it is very easy to peel out. So we can, for in my experiment, I have tried to, from one leaf, I have made 4 to 5 templates. But one thing we need to be careful is that after many repeated ones, the property of what it's reduced. We have checked the water contact angle. So like the first PDMS template, comparing with the last one, like 5th or 4th one, the contact angle was reduced. So if we are using for the first time, is better, but we can repeatedly use it when you are using the fresh lotus leaf. The dried one you cannot use for a long time. It will not get peeled out properly. So fresh one, you can use it for a long time, but still, for better properties, use the first one.
Okay, there is one more question from Yuka S. Lakshmi. Can pervaporation membrane block out the pollutants too? Can pervaporation membrane block out the pollutants?
That is also a good question, but we have only checked for seawater desalination. So that is a very tricky question. So I think there must be something to do with that. Pollutants also, because in our work, we have just used the pervaporation machine, which allows the water, if we are using hydrophilic one, it allows the water to flow out. And so we haven't checked about other pollutants. So I think that I need to check for it. That was a good question.
Okay.
No, there is no other questions. So one question, can I ask one question? That normally this lotus leaf actually papilla is there. I think you are talking about the papilla. That's the growth. On that growth, there is actually wax coating is there, wax crystals. So how can you imitate that wax crystals in your system?
Okay. Like before we use the lotus leaf, we have cleaned it in a high way. Like we use the water, which is like running water. We have used it for a long time. So the lotus leaf is taken, it is washed properly, and in a running water, it is wiped out. Even after wiping out, we have repeatedly used the running water to clean it. So, and we are just focusing to get the patterns of lotus leaf so that the PDMS can get the lotus leaf. So we haven't checked the PDMS have some wax on it. I think after the cleaning process, maybe this wax have been fully removed, but we haven't checked after cleaning whether there will be wax remaining. So our aim was just to get the patterns on the PDMS.
Okay, Dr. Anuj, I think we do not have much. Okay, one more question is there. The disposed or reused? Sodium chloride is the NaCl residue disposed or reused? So one student.
For the desalination work, the NaCl residue is for other applications we have checked. So before before we use the NaCl, we check its properties. I cannot disclose everything, but still, like we check its content. Like we need to get an approximate value of 153 or something for the one of the experiment. So we have checked the property of NaCl. For one membrane, if we are using a NaCl solution for one membrane, the same solution we have used for repeated cycles for another membranes too.
Okay, Dr. Anuj, I think there is no other question
Okay.
in the chat box. I think you can go for the conclusion.
For a nice talk and of course a very interesting question answer session also. So we had a very nice interaction. So now I request Vidya to propose the vote of thanks. Vidya?
Thank you, sir. Dear all, it was a wonderful talk, and I would like to thank Dr. Susan Zachariah for accepting our invitation and delivering such a wonderful, informative talk. Thank you, madam. And the question answer session was so interactive. Thank you. I would like to thank Dr. Anuj Vargeese for chairing this session. Thank you, sir. And I would like to thank all the participants for the interactive participation. Thank you.
Opportunity. I think we can wind up this session by now. Okay, so
Thank you so much for giving this opportunity.
Thank you, Dr. Susan.
Thank you so much for giving this opportunity. Thank you.